Hello.
Hello. Hello,
Yeah.
Robert.
Hi, Klaus. Hi, audience. Yeah, this is episode 20 of Fun with RELUX, and today it's about measuring grids and points, and quite deep and interesting topic about measurement of light in general. This is one of the USPs of RELUX,
Yes,
that we take really measurement grids and points and have values on lighting and not just visual impressions. And yeah,
that's one of our main goals for a light calculation program is to have to simulate a measurement, not only to make visualization, nice pictures or something like that, that we can make a simulation of measurements, and these simulations will be used that we are that the lighting is according the regulamentations and the standards, and and this is one of our major things, and we want to show you today a little bit about the details, also to remember some of you what is possible, where are these options, and yes, that's our goal for today.
Yeah. So a bit more nerdy maybe, but we try to keep it on a general level, not to go too deep. We have in preparation of this, we have thought about some more stuff, but we have to concentrate on the core stuff because the topic is quite huge, and but it's also important for all of you who are doing lighting design or cares about lighting values. It's important to know what is this value is about and where it comes from, and how it should be used and or not. That's why we think it's quite important. It's one of the fundamentals of our application and also our complete lighting calculation business, that we know what to calculate and what to use in which way. Yeah, today we show you some samples in RELUX Desktop. So we will soon start up the application and show you graphically what it's about with grids and points. And I start with a piece of a room for an indoor calculation scenario, and Klaus will follow with an outdoor scenario, because there's also different kind of grids and measures and values for indoor and outdoor. It's a bit separated, and we try to show you both. And yeah, so the best is we start right away. So I will start with the indoor world. Just have to find the cursor here, and to avoid the presentation, I have to share the screen, sorry. So now I share the screen again, and since we don't need more, we have prepared one room, and in this one room we have two tables, and you can see right away we have a lot of rectangles, red rectangles, red vectors in the scene, and everything which is red means this is a calculation, and the calculation surface and calculation area. And in 3D it looks a bit of more graphically. So we have here a simple office room, and you can start by seeing we have also these red areas on the walls, also on the ceiling, on the ground also, and this we call evaluation area. An evaluation area is some kind of grouping of all the surfaces which houses the room, or which is the border of the room in terms of surfaces, and this is for us the evaluation area. And you can also see that the walls, also the ceilings, have this half a meter tightness, this bounding area. This is meant to the standards that we do not need to have to complete wall. It's okay, and it's also according to standards to make a lower area cause of uniformity, and also the usage of the walls is limited to a more centralized area. And this is quite fine, and we have simulated here in this room. In general, we try with these measurement areas, also with the grid points on these measurement areas, we try to hit the measurement. So the goal of RELUX in lighting calculation is to try to simulate the measurement, the real on-site measurement, just in a mathematically lighting environment virtually, that we try to hit the same values with the same spots, with the same conditions in the same matter. So that's why we are in kind of simulating and measurement environment, and all this grid measuring areas, grid points, calculation points are based on measurements. Yeah.
Okay.
In general.
Yeah. Maybe it would be interesting to show the grid points in the application.
Yeah.
So it is not this red areas are representing, we call the measuring area, but in reality it is a kind of calculation points, and here we can activate them in our view, also in the 3D view, that or also in the 2D view. Because we have already run a calculation actually, so we will not only see the points, so we will also see the result at that given position.
Yeah.
And by selecting one or another surface, you can see on the selected surfaces the grid points and the calculation, and if it is calculated as well with the results.
Yeah. This is also important to understand that all these measurement surfaces has not a value from the surface kind of shape. The values for a surface comes from the points, from the grid points of the surface. So measuring of illumination is always measuring, and also calculation of an illumination point is always on the point. It's always on dot. It's not possible to have an area which is measured. You always just have points, and this points in total, the average of these points is the value for the surface. That's why we also call it average illumination or average illuminance on the surfaces. It's not an value for the surface. We have just single dots, single points to measure, and not just single points. We also calculate and also measure. It's the same. We also have a direction of measurement. So it's a huge difference if you measure the light from up to down, straight from one direction, or from different directions. This has an impact on the measurement, as it also have on the calculation. A good example is here we have here horizontal points. So you can see here the small vectors, the small lines, which demonstrates the direction of measurement. And we have here a good example with this board, kind of board here. And on this board we have also vertical illuminance values, because we measure here from inside the room to this board. And we can also select here different kinds of directions. And if we change it here to horizontal, so we have here values which have here not really a sense from above. So each point on this board is also measured from above, but there's not an viewing direction. So this value is kind of without any sense. And this is the main direction forwards into the room from the board. So just keep in mind, every illumination is based on points with a direction, with a vector, to have the right direction of the light. There are also some measuring points also on the grid scale, which is not just from one direction. We can also collect from multiple directions the illuminance. And for example, we have also recovered and also reflected in the 12464 standard the cylindrical values. And therefore, I have just one sample here on this background area. I have also prepared, we can see it here, this cylindrical values. This means here on this small circles, we calculated the light from all directions on a cylinder. And this value is great to have an impression on how good you can see faces or heads of humans for visual communications. And that's why also I put this area on the area where probably the heads of sitting people is, and you can easily adjust this height of this cylindrical calculation points on the grid to another level if you have standing people and so on. Just an example for different kinds of measurement points. Talking about this, I have also one area. It's here the background area down below, which has multiple points on it. So it's also possible in RELUX that you have one surface, one measuring area with multiple directions, with multiple grid points. And this you can see here with this calculation dialog. And here you can see this background area has an horizontal illumination. We have a cylindrical illumination on a different height. And we have also an UGR value table also on this grid points with a certain direction. Because UGR, you need an observer with a direction. You can change this direction of the observer here and also the height of the UGR values. And of course, you can add several of more different calculation points. For example, also a hemispherical value of elements, so that the complete upper kind of sphere is in calculation of all these directions. Camera position, UGR, GR, glare, and also the daylight glare probability you can also have on a calculation grid. And of course, you can also change the calculation grid size. We have here in good and wise default from the standards. There's one European standard with an calculation method to calculate the grid points on a calculation area. There's a quite simple logarithmic function behind this, and with this function you can calculate the amount of calculation points on a surface. And this is the default situation. If you put in a calculation area into RELUX, it's automatically give you the default, which is according to standard, and which is also the same grid which happens in real life measuring situations. So you have the same grid size, grid distances out of a real measurement situation, which is good, and which brings you to the same values as in real measurement, which was the goal in the end. Of course, it's possible to change this value. You can adapt, you can raise the values of points. If you raise the values of points, you get a better result in a way that you have more points and better average, so a more intensive view on the lighting situation on the surface. You get a not so good in most situations you get a not so good uniformity value. But it's also something else as you have as uniformity values in the standards. If you have the uniformity values out of a standard for an office desk, for example, 0.6, this needs to be in the same grid out of the standard. So the standards describe a grid, and you need to cover this grid in also to have in comparison to this uniformity. So that's why it's important, if you compare to a standard, use the same grid as the standard describes it, because the grid also has an impact on the uniformity in general. Okay, and of course you can change it here to whatever you want to have. And if with more calculation points, you have just better formed isolux lines and just a better impression what happens in terms of lighting on the surfaces. Okay, and I also have here two desks. This is something which is also important to understand and to know. If you have not a clue in the room, where are the desks or where is the task area? If you are uncertain or if you just don't know where is the task happening in this room, then the default situation is that you create some kind of room covering task area called the evaluation area, or the what's an other English impression evaluation area? It's the evaluation area.
Reference plane.
Reference plane. It calls the different wordings. The reference plane. And this is in a way a task area covering the complete room except of this half a meter border area to the walls. And with this area, you assume that everywhere in the room can happen your task. For example, an office desk. But this is in a way a waste of energy. And the founders of the standardization of 12464 wants you as a lighting designer to make zones, to define the task areas where the task happening. In our sample here, we have two desks, and these two desks are just the area where we need this 500 lux, and not of the rest of the room. So this is saving energy and also make a better down to the spot lighting situation. Of course, then with a surrounding area, because a hard cut of this 500 lux to the rest of the room is not nice to the eyes. That's why we have this surrounding area, half a meter. This comes automatically with the calculation area, and it can also be adapted. And I also want to show you that it's possible to define by yourself what do you have an understanding of what is the task area. For example, here, this task area I put in here just covers a part of the table. Part of the table means just in this area, the tasks of an office worker can happen, not on this side areas. So we can also make it wider, bigger, assuming that you have also tasks outside this table desk. It's also possible that you need this this lighting situation also with a bit of an offset of this table desk. Also possible, but this is up to you who does the zoning in what really happens on the situation. This is important to at least to communicate, and also for you to important to define where is the task happening. It's not always just the table desk. It can also be more as the table, can exactly the table or less in the table. Most important is the communication, that you tell the client, okay, this for me is the zone where this and that happenings, and then the client can say, okay, no, it's more, it's less, whatever. But often office desks, it's quite simple, but there are more complex situations where zoning is more complicated. Here, for example, I have put an just the area of the table covering plate as an area where the tasks of an office situation can happening. So this is also one of the simple approaches. And of course, we have here the surrounding area. And you can also see here the grid points are also possible if you have a polygonal piece of a desk of the task area. This is possible, but then of course you just get the grid points which are inside this polygonal arrangement. What you can also see here is it's also possible in RELUX that you can just take single calculation points, single calculation dots. Here, for example, this is a calculation point for a UGR value, an RUG value in use speech. And here you have the value of 15 UGR in this direction. And this point comes also with a direction where you can see in which direction you have this UGR value. Of course, you can adjust this value or this viewing position. It's the same also with this daylight glare probability. You have also a point with a direction where the observer is looking in. And of course, any single direction has an other value, which you can see in the outputs. There's some kind of table. This is possible to show calculation results, UGR left. Then you can see here. This is the impact of UGR values to this viewing section you have. Okay, what else we have? Guess I'm close to have it all described. Yeah. I guess I'm done with my points, so I can handle over nicely. Or do we have a question?
No. Everything is fine. Okay. I will switch to exterior scenes, which is in general there are not so big difference of yes, yeah, close this view so that we don't have a conflict. I have prepared a small exterior scene with a road and here a small sports field, a tennis plate for the illustration. In our road module, street calculation module, when we from the beginning, when we here start with calculation roads or tunnels, therefore we have all the grids will be created automatically depending on the standards from the road lighting, the 13201. Which is a little bit different from that from the 12464, but this is not really things. The thing is a little bit, we have here inside of exterior, we have some very special grid points and also some very special measuring elements which are only used in the exterior scene. And I will start with with what Robert shows for the interior room, the possibility to make calculation for UGR observers. And in the corresponding way, we have here in the exterior the possibility for using GR or RG.
In the past, GR, now RG.
This is a little bit
the ratio of Claire. Yeah.
Now it's the ratio Claire, and in the past this was the Claire ratio.
Yep.
So it's a little bit, we have to train this a little bit. And we can click here, select one point, and then place it. The important thing here is a little bit that the next I click to choose the position, and then I give the main direction of the I click on the main direction of the observer. And one important thing is that that I have to take care. I make this now in this situation. It was placed to the road, but I want to have it here on my sports field. This is important that they are linked together. Because the background illuminance which is needed for the glare calculation comes from the illuminance values of this. Sorry, we have chosen our German project, which means the tennis court here at this place as the measuring field of the tennis court. And then we have here in the GR values, we have here all the possibilities of the settings as well as the viewing. In this case, we have the main direction of the viewing, and in this example, we will now make 180 degrees in each direction, but we can also limit this to 90 degrees, or in some cases, there are some samples it is needed to limit this to 45 degrees or something like else. Also, you have the possibility to set all the other parameters which are necessary for this kind of observer calculation. And when I run the calculation, I will afterwards here in my exterior scene, calculation results, glare rating, we will now have also the possibility to show it is in a form of a diagram to check if this if the glare ratio here is okay or not, and everything in that way. Also, this is possible to make this with this is many of the users did not know this possibility, that we have the possibility also to do in a similar way to make the TE, the threshold calculation, as most or many of you will know it from road lighting, where this runs automatically when you're starting a luminance calculation for road lighting. And here, but you have also the possibility here in exterior scenes by clicking to place the TE observer and give a direction of step points. One big difference between TE and GR value. GR value is an observer at one position who's rotating his head. And for the TE value, it is an observer that starts at one point and goes in step through a scene or along a road or wherever you need to have the calculation. After the calculation, you will have as a result a TE curve which is corresponding to your actual scene. I guess this is also sometimes very interesting to making this displacement. These are the special observer calculations we have inside of the program. We have also a third one. This is the luminous intensity point. The luminous intensity point is useful for light emission, or if light is disturbing the persons. And here we have in some standards like the sports, there is limiting just the luminous intensity. But in some other also standards, it makes a thing which is called the K calculation, where the luminance calculation of the lighting of the scene lighting area is taken into account, and we can place them.
I guess it's already placed.
Okay, a little bit.
Yeah, this.
And here we will then have the luminous intensity values. So this is now here a little bit. I have to put it to a little bit outside. And sorry, I have at the moment there is only we have missing the license for the K calculation. So it is just displaying the luminous intensity. But this works also. We can give you
also a reminder. This KCal functionality is bound to a special license.
It's bound to a special license. You can use it for the luminous intensity. You can set here a limit, and then you will see here the results. And if you then under the limit, then it will become mild red. Oh, no. So here, for example, now you will see here that this luminaire here, for example, is producing a problem about too high luminous intensity. And a similar way goes with the K-calc. Okay. The next thing I want to show you is we have in exterior lighting, we have some very special measuring grids. And the first I want to show is the pedestrian crossing. You can draw a pedestrian measuring surface for a pedestrian crossing here by clicking on the along on the road, and then shift to the other side where you have the white. And automatically the program creates the waiting area on the left, on the right side, on the road. Take a look to the 3D. It looks like this. And here for this measuring surface, there are very special grid points which are related to standards. And we have the German standard, the Swiss standard, and the Italian standard available in the program. And when I now make this calculation,
this pedestrians is sadly not European. There's just national standards on it.
So each country has a little bit his own. In the basic, they are all using the same, or it's similar. So the main criteria is the minimum vertical illuminance in a 1 meter height in the central line transversal to the pedestrian crossing. And in some countries, like here in Germany, they also take this corners into an account in the Swiss standards, for example. Not in the German standard. It depends what kind of lighting system is used, and so. But here we will see now that here we have a very special grid, and we will see also this grid points here, also in the same way as we have shown it before. Another one which is a little bit special for exterior scenes is here. We will find it here in this exterior road scene. Is the roundabout. I define a roundabout by 2 clicks, the inner circle and the outer circle. And then we will have the grid optionally in a radial way, the grid points here in a radial way, or if we prefer the not this one. If we prefer the standard grid settings from the 12464, we can switch between these 2 styles in the grid. Okay, and the last one I want to show is the general road. The general road can also be used also in interior scenes. The interesting thing here is a little bit, you will try this surface not by drawing a shape, you will drawing a line. In this example, you can simulate, for example, a curve. And at the last point, press the enter, and then you can give the width of this line. And for the grids, there's a small problem with the refresh. Let me make just a short calculate it. And then we will also see here this grid lines, and the special thing, they are now transversal to the line of the road, as we typically have this for roads. But you can also use this measuring area also in interior scenes for anything you want. And the last thing, which is a little bit special for our exterior measuring surfaces, when we take here a standard measuring surface and we can add the nominal values, we will use for standard measuring areas here the standard luminance classes or illuminance classes from the 201 part 1 defined. In standard exterior scenes, we can only calculate the illuminance value, so we only C and P are useful. M classes are only be used in the road lighting module. But if we're using as a measuring surface here by entering an evaluation area from this part or a task area, as Robert has shown it in the interior scene, we'll make it a little bit bigger. You will also see here when we change the size of the surfaces that the amount of measuring points automatically adjust.
Dynamically.
Yeah. Dynamically, yes. And if we then here click on profile, we can add now the usage profiles from the 12464, typically from the part 2, exterior working places for exterior, and we can choose here for example, don't know, whatever is possible here for exterior lighting. We know that this is sometimes a little bit confusing to users, and we have still this on our to-do list to make this a little bit clearer. Actually, this is the situation. Placing a standard measuring surface, you will have the lighting classes, M, C, P. And for task areas or evaluation areas, which can also be used in exterior scenes, you can choose from the usage profiles according to 12464-12464.
You can also eliminate the surrounding area to 0 if you like. So the surrounding area is also adaptable to nothing. So we can have also just a task area without the surrounding, and of course you can also extend the surrounding to whatever you want to have. In outdoors, it makes not really sense to have a surrounding. But yeah, it's also possible.
Yes, so we can click here, and we have here you can switch off. Then we have no surrounding.
Exactly. Yeah.
Good. Okay, so that's all what we want to show you here in the program today. And now we will take a look to your questions. One moment, please.
Okay. At the moment, there's no question.
At the moment, there is no question. So
please feel free to ask us anything about grid points, measuring areas, calculations of phases, points, values, standards.
We hope there is no technical problem.
Yeah.
Okay. So
also fine for us if you have no question. Yeah. We could also have a look in the chat. The chat is also empty. Okay. If you have the occasion, we are on next week on the Licht conference. It's a German-speaking conference, but maybe you also are in the area or in a German-speaking country and just checking this English version of this episode. Then next week is Salzburg, a big European lighting conference where Klaus and me we are also participating together all the 3 days, and also have presentations for lighting technical stuff, which are quite interesting, at least for us, maybe also for you. And yeah, we see just the test question from our team, which is great. So there's no technical issue, but it's okay. Then we assume that it's everything is fine, and you have no questions for calculation grids. Next episode is about tunnel lighting, tunnel planning with RELUX tunnel. where Klaus is the biggest expert on earth. Yeah. And it's on the 27th of April. 27th of April, same time as today. We're talking about tunnel.
We're talking not too deep in the details. It's also a little bit to explain users which are a little bit from outside to give an idea what this program really makes and what it is good for.
Okay.
Okay. Thank you. Hope you enjoyed it and see you next time.
Yeah. See you.
Bye.
Bye bye.